Good morning dear student and welcome to my channel, that is Easy Chemistry by SBG. Today we will see the molecularity of reaction. Molecularity of reaction means the number of atoms or molecules or even ion taking part in the reaction. That number is the molecularity of the reaction. Let us see the definition. The number of atoms or molecules atoms or molecules which collides together at the same time for the reaction to occur or to complete. This is a definition of the molecularity of the reaction. Reactions are classified in terms of molecularity as a unimolecular. If only one molecule is involved in the reaction, then it will be the unimolecular. Then bimolecular if two molecules are taking part in the reaction, and termolecular if three molecules are taking part in the reaction. According to that, the reactions are classified. Let us see some example. Unimolecular reaction. For example, phosphorus pentachloride get converted into phosphorus trichloride plus chlorine gas. It is an unimolecular reaction because only one molecule, that is phosphorus pentachloride, is involved in the reaction. Second type of the reaction is bimolecular reaction. Bimolecular reaction. Bi means two, so obviously the two molecules will be involved. The ethyl acetate reacts with sodium hydroxide, NaOH, to give sodium salt of acetate, sodium acetate plus ethanol, C2H5OH. The two molecules involved in the reaction, that's why it is a bimolecular reaction. Third type is a termolecular reaction. Termolecular reaction. Three molecules will be involved in the reaction. So, example will be the ferric chloride plus stannous chloride. It is an example of redox reaction. It will give the ferrous chloride plus stannic chloride. So total 3 molecules involved in the reaction, 2 moles of ferric chloride and 1 mole of stannous chloride, and that's why it is a termolecular reaction, or we can call it as a trimolecular reaction. Only a few termolecular reactions are known, while no reactions having the molecularity more than 3 is known, because more than the 3 molecules may not mutually collide with each other, and that may be the complex reaction. The next subtopic is the determination of molecularity. Determination of molecularity. In case of a simple reaction, that is elementary reaction, the molecularity is the sum of the molecules of the different reactants. Molecules or maybe the atoms or ions, those species involved in the chemical reaction. Just make the sum of all the molecules, and these molecules must be represented in the balanced chemical equation, and from that we can say the molecularity. For example, take some example of elementary reaction. For simple or elementary reaction, chemical reaction example is O2F2 gives O2 plus F2. Now only one molecule is involved here, reactant is only one, that's why it is an unimolecular reaction. Unimolecular reaction. Second example is twice HI will give the H2 plus I2. The 2 moles of the HI is involved here in this reaction, that's why it is an bimolecular reaction. Third example is a nitric oxide NO plus O2 gives the twice NO2. The 3 molecules is involved in this reaction. See the reactant 2 moles of the NO plus O2, that's why it is a termolecular reaction. Molecular reaction. Now this is an elementary reaction, that's why it is easy to calculate the molecularity, unimolecular, bimolecular or trimolecular or termolecular. But in case of the complex reaction, that is multi-step reactions, the atoms, molecules or ions participating in rate determining step decides the molecularity. Among the many steps in the complex reaction, number of steps involved, and among the many steps the slowest step is the rate determining step. So for complex reaction means the multi-step reaction. Step reaction. The slowest step is the rate determining step. Slowest steps is the rate determining step. Determining step. Rate determining step. And to calculate the molecularity for the complex reaction, the number of atoms or molecules or ions or those species, those reactant ions involved in rate determining step. Rate determining steps means the slowest step, the number of atoms or molecules or ions involved in the rate determining step, just make the total. Now take an example. Consider the reaction. For example, HbRO3 plus 6 mole of HI gives HbR plus thrice H2O plus thrice I2. This is a complex reaction. The number of steps involving are as, see the steps. First step, HbRO3 plus 1 mole of hydroiodic acid, and this step is an slow step. It gives HbRO2 plus HiO2, sorry, HiO here. This is a slow step. Second step of this complex reaction is HbRO2, which is formed in the first step, plus 4 mole of Hi, and this is a fast reaction. It gives HbR plus twice H2O plus twice I2. Third step of the reaction is HiO, which is formed in the first step, HiO plus 1 mole of hydroiodic acid, and this third step is also the fast one, and it gives H2O plus I2. If we make the sum of all the reaction, then we will get that complex reaction. Out of these 3 steps, only first step is the slow, and it is a rate determining step, and the number of molecules involved in the slow step, that is rate determining step, is 2. That's why molecularity of this complex reaction is 2. Hence Here two molecules participate in the slowest step. Thus, reaction is of bimolecular type. Thus, reaction is of bimolecular type. In this way, we can determine the molecularity of reaction. The characteristics of molecularity. Characteristics of molecularity. Characteristic of molecularities are, first characteristic is the molecularity of a reaction is always a whole number because it is just sum of the number of reactant involved in the reaction. So molecularity of a reaction is always a whole number. Whole number means it is not the fraction or the zero even. Second characteristic of the molecularity, it does not provide any idea about the rate. It does not provide any idea about the rate. Or mechanism of the reaction. Rate or mechanism of the reaction. How the reaction is taking place is not provided by the molecularity. In next lecture we will see the important topic, that is order of reaction. Till, if you like my video, then please share, subscribe and press the bell icon so whenever I add the new video you will get the notification. Thank you.